Assalamu alaikum.
Walaikum assalam. Yes, how are you, Saad?
I'm good. How are you?
I am also good. Okay, so we have to complete the whole chapter by today because so that we could start new unit next week. Let me tell you the remaining topics. We have to discuss conjugate base and conjugate acid. That is something new to you. Other than this, we have to do detail of titration. You know, we are using some indicators, and we have to discuss that what indicators we are going to use. And we have to discuss one more thing. I mean, what is titration when you react acid and base together? So we have to discuss that if you are reacting a strong acid with weak base, or you are reacting acid with strong base, or if you are reacting a strong base and a strong acid together, or if you are reacting weak acid and weak base together. So what will be the result of titration? That's what we have to discuss today. That is little tricky, but that is not that much difficult. Let's start and finish the unit. Okay, so let's start the
Also have to do
topic.
the
Um,
net ionic equations.
we have already done with ionic equation. Ionic equations are those equations in which we usually break any compound into two things like NaCl, and that is broken into sodium positive and chlorine negative. We have already done with ionic equation. You can check your notes. If we haven't done it, you can inform me. I'll help you out again. Okay?
Okay, no problem. No problem.
Okay.
We can move.
Okay. Mm, wait a
So
little.
we're gonna continue titration, right?
Yes, we have to finish all types of titration. There are 4 types of titration and indicators and conjugate acid. We have to finish all that stuff. Okay. At the end of the class, I'll let you know about ionic equations again so that you could check out your notes again. Okay. So, yes, what we have to do today is titrations. First of all, what is titration? Titration, that is experimental thing. You can say that is experimental thing, that how can you react an acid and base together. But this is not that much easy. You know, neutralization is a reaction and titration is a process. Titration, um, you can say the neutralization is a reaction in which you react one acid and base together, and as a result of that reaction you get salt and water. As a result you get salt and water. So neutralization is a process. A neutralization is a process in which you react one acid and one base together to to get salt and water. So neutralization is a reaction, that is a chemical reaction. But what is titration? Titration is, you can say titration is experimental process. Means we never discuss in theory that what happened when you react a strong acid with a strong base. We have different type of acid. I mean, we just discussed that we have a strong acid and this weak acid. We do have some strong base and the weak base. So neutralization reaction is simple. Acid, base react together to give you salt and water. Simple. That is a reaction. But when you are working physically, so there is some thing which you have to notice. I mean, you should know when you are reacting a strong acid and a strong base together, what type of reaction there will be. You know, if you are reacting a strong acid like HCl, H2SO4, HNO3, hydrogen, wait, other one is hydrochloric acid and hydrobromic acid, HBr, HI. We have different type of acid, HF. So if you are reacting a strong acid with a strong base, like NaOH, like calcium hydroxide, like potassium hydroxide. So whenever you react a strong acid and a strong base together, as a result of that, you will get salt and water. This is the complete neutralization. When you react a strong acid and a strong base together, there will be complete neutralization. There will be complete neutralization. It means when you are reacting, complete neutralization means every acidic particle, every basic particle have been reacted together to give you salt and water. After the result, I mean, when you are reacting acid and base together, so after the reaction inside the container, you will not be having any acidic particle or any basic particle. There will be only salt and water. This is called complete neutralization, the best neutralization, when you react a strong acid and a strong base together. So what happened when you react a strong acid and weak base, or weak acid and a strong base? I mean, if you are reacting them physically in your lab, so you are doing titration, but there will not be complete neutralization. How acid react with the base? First, this is the first question. You can select any stronger acid. For example, we can select any HCl. HCl is the stronger acid, and you can select any base. For example, NaOH. Everyone knows, I guess, that all the acids are those substances which can donate H plus ion, and all the bases are those things which can accept H plus ion or which can give you OH negative ion. Now we are using sodium hydroxide. Now sodium hydroxide cannot accept H plus ion, but it can donate OH negative ion. So this is a base. Okay. So now, what is a strong acid? Stronger acids are those acids which completely dissociate into ions. What are stronger bases? The stronger bases are those bases which can completely dissociate into its ion. Okay, so when you are reacting a stronger acid and a stronger base together, so that stronger acid and a stronger base both are completely dissociating into its ion, and they are giving you H positive ion, and they are giving you OH negative ion. So all the H positive ion from the acid and all the OH negative ion from the base together, they will give you water. Now inside the solution, or you can say in the final solution, I mean after the reaction, the solution you are getting, there will not be any H positive ion left from the acid, and there will not be any OH negative ion in the solution. Reason, all the H plus ion, OH negative ions have been reacted together, and they have given you salt and water, complete neutralization. After the reaction, there will be salt and water only. There will not be any H positive ion, and there will not be any OH negative ion. This is called complete neutralization, when you react a strong acid and a strong base together. Now let's discuss what happens when you react something weak. For example, let's select some. Okay, let's take a stronger acid. Okay, the acid is stronger, means you can say HCl or any stronger acid, and you can consider weak base here. So stronger acid and weak base. What happened now? This is something which we have to focus. Weak base. Okay, we are using a stronger acid. A stronger acid completely dissociate into ions. It will give you a lot of H plus ion. You know, presence of H plus ion can tell you about the acidity of the solution. The acid is stronger. It is showing its all acidic properties. It is showing its all acidic properties. So a stronger acid will give you a lot of H plus ion. For example, let's consider it is giving you 100 H positive ion because acid is stronger. Okay. On the other hand, we have weak base. Weak base? Weak base is that base which never, I mean, weak bases never completely dissociate into their ions. For example, you can say that this weak base is ammonia. What ammonia usually do? Ammonia is that weak base which can accept H plus ion, and that can give you OH negative ion also. So let's consider OH negative ion. So weak base will not completely dissociate into ions. means it will not give you a lot of OH negative ion, means the weak base is giving you OH negative ion. I mean, this is a base now. It will dissociate into its ion. It will give you OH negative ion, but there will be less OH negative ion. Let's say because this is a weak base, so it is giving you only 20 OH negative ions. It depends. If you are using weakest base, you will get very least number of OH negative ion. Now see the difference. I have taken a stronger acid like HCl, HNO3, H2SO4, HBr or HI, and I have taken a weak base like ammonia or in any hydroxide of transition metal is considered as a weak base like zinc hydroxide, copper hydroxide, silver hydroxide. There could be any weak base. You should know about the weak base and the stronger base. Okay. A stronger acid is giving you a lot of H positive ion, 100 H positive ion. The weak base is giving you only 20 OH negative ions. Okay, we are doing titration, means we are doing this thing physically. Okay. What is titration? Means we are doing some neutralization reaction. You have to produce something neutral. Okay. Neutral thing means, for example, we are going to produce water. Now there will be less neutral thing produced at the product side. Means less number of water molecule will produce. How we make water molecule? H positive and OH negative. Together, they will give you water molecule. Now see, there are 100 H positive ions, but there are only 20 OH negative ions. So 20 OH negative ions will react with 20 H positive ion and they will give you 20 water molecules. Okay. All the OH negative ions will be disappear now because 20 OH negative ions have been converted into the water molecule. And what about H positive ion? Only 20 H positive ion have been converted into the water, but still there are 80 H positive ions. Still there are 80 H positive ions. Why? Because you have used a stronger acid that has given you a lot of H positive ion, but you, on the other hand, you are using weak base that is giving you very least number of OH negative ion. That is giving you very least number of OH negative ion. So there you, I mean, in this case, you don't have more OH negative ion, which could react with these remaining H positive ion to give neutralization reaction. So there you can say the neutralization, I mean, this is not complete neutralization. This is partial neutralization because you are using a weak base here. So the final solution will not be neutral. I mean, why we are reacting acid and base together? So that acid could kill the basicity of the base or base can kill the acidity of the acid. But here, I mean, if both are stronger, they both can neutralize each other and they will give you a neutral solution. But right now, in this case, when you're using a stronger acid
Wait,
and the weak
before
base,
you continue,
yes,
can I go to the bathroom real quick?
yes.
Okay, thank you.
Oh, sorry. Yes. Okay, continue. Um,
Yes.
Okay, so what we just did is stronger acid and weak base. So after the reaction, you will get some acidic solution. Now we just did this example. You are using a stronger acid and weak base, and a stronger acid is giving you a lot of H positive ion, and weak base is giving you less OH negative ion. So all the OH negative ions will react with H positive ion, and together they will give you water. But it's still the final solution will not be neutral. That's what I told you. The final solution will not be neutral because still there are some acidic ions left unreacted because you have used a stronger acid that has given you a lot of H positive ion. So still there are some H positive ions left in the solution. H positive ion is coming from the acid, means the final solution is acidic, not the neutral. The final solution will be acidic in this case because still few acidic particles left unreacted here. Okay, what is the example of the reaction? You should know which stronger acid could react with the base and it will give you some acidic solution. You can pick any stronger acid. For example, we can pick a stronger acid like H2SO4 because they may ask you about the example in the exams. H2SO4 is one of the stronger acid that is more stronger than HCl. H2SO4. We have different sample of H2SO4. Few are more stronger and few are less stronger. Okay, H2SO4, the strongest acid. Let's consider a weak base. Now it's up to you. We have one commonest weak base, which is NH3, the ammonia. This is the commonest weak base, ammonia. Now it's up to you. You can use ammonia for the example, or you can use any hydroxide of transition metal. All the hydroxides of transition metal, all the hydroxides of transition metals are weak bases. You can note down the examples. Silver hydroxide. Okay, wait. Who else is there in transition metal? Zinc hydroxide, copper hydroxide. Chromium doesn't make hydroxide. We are not having hydroxide of chromium. So silver hydroxide, copper hydroxide, zinc hydroxide, and iron hydroxide. These are most common. All other transition metals are nearly unreactive. So we are not making hydroxide of those. So you can use any transition metal hydroxide here, or you can use ammonia. After the reaction, you will get acidic solution because ammonia is a weak base. So a lot of acidic particles will be left here unreacted. So after the reaction, you will get acidic solution. Now, if you want to know the product here, so let me tell you, you will get, this is ammonia. Yes, it will give you ammonium sulfate, NH3SO4. It will give you ammonium sulfate. You don't need to know the product here. You should know that what type of solution you will get. But let me tell you, you will get ammonium sulfate. And keep in your mind, H2SO4, H2SO4 is acid. All the acids are aqueous, means acids have some water molecule. All the acids are aqueous. So there will be some water molecules along with H2SO4. So you will get ammonia. So this is called ammonium sulfate. This is NH4, 2, and SO4. This is the formula. Yes, ammonium sulfate, and you will get some water molecules. So this is how you will do some neutralization process. Let me tell you, we never write water at the product side whenever there is ammonia involved. Simple. We always write one thing, a salt. Salt is something which is neutral. Water is something which is neutral. Okay. So this is the example of the titration in which you are using a stronger acid and you are using a weak base. Okay, let's move. Final solution will be acidic here. Now let's change the situation. The third type of situation. First type, a stronger acid, a stronger base. Second type, a stronger acid, weak base. Now we can do weak acid and a stronger base. Okay. Now, this is very simple for you, weak acid and a stronger base. So, weak acid. Acid is weak here. It means acid will not give you a lot of H positive ion. You can say acid is giving you only 20% H positive ion because that is a weak acid. It is giving you few H positive ion. What about a strong base? Strong base, it will give you a lot of OH negative ion. This is totally opposite as compared to the previous example. It will give, for example, the base is much stronger. It will give you 100% OH negative ion, a lot of OH negative ion. Okay. So we are doing titration. We are reacting this stronger base with the weak acid. So basically ions will react now. So OH negative ion will react with H positive ion. There are only few H positive ion. So you can say only 20 H positive ion will react with 20 OH negative ions, and you will get 20 molecules of water here. 20 H positive ions will react with 20 OH negative ions. You will get only 20 molecules of water. There are still a lot of OH negative ions left in the solution because you have used weak acid here. There are a lot of OH negative ions left in the solution. So OH negative ions, these are the ions from the base. Few OH negative ions have been reacted with few H positive ion because you have used weak acid here that is giving you few H positive ions. So your final solution has few OH negative ions. OH negative ions are the ions of the base. It means the final solution will be basic here. In this case, the final solution will be basic. In previous example, the final solution will be acidic. But in this example, the final solution will be basic because you are using a stronger base. A lot of basic particles are still there in the solution, which are not neutralized because there are very less number of H positive ions. So final solution will be basic because you are using a stronger base. This is third type of titration. And you can note down any example of weak acid and a stronger base. Like in weak acid, you can say in weak acid we have ethanoic acid, means all the organic acids, or you can say the easiest one, HCN, hydrogen cyanide. HCN is the weak acid which we are not using in our chemistry, but you should know the example. Weak acid is hydrogen cyanide. That is also organic acid, or you can say ethanoic acid, methanoic acid, that they are the weak acid. And you can select any stronger base, for example, NaOH. That is very common as a stronger base, NaOH. You can react HCN with NaOH, and you will get now you will get some complex salt here. You don't have to work on the product, but you should know that you will get basic solution here because you have used a stronger base. Because in this case, you will get some ethanoate or cyanide salt, which is not included at this point. So you don't have to work on the product here. So this is the example of another titration. The final solution will be basic. And keep in your mind, we are doing titration, means the physical process. It means we are using some indicators here. We have to discuss indicators also. Every titration require different indicator. For example, this is the example. This is the titration in which we are using weak acid and a strong base, and the final solution is basic. So we have to use an indicator which could give you some darker color in a basic solution, so that you should know that there is partial neutralization, and my final solution is basic. I mean, how would we know that final solution is basic here? How can we check that final solution is basic? So we have indicators. Indicators can change color according to the solution. So we have to use a specific indicator in this case. which could show you some darker shade in basic solution so that you should know, okay, so the final solution is basic here, we have to do indicator. But before that, let's do the fourth type of titration in which you have to use weak acid and weak base. What happened here? Weak acid and weak base. When you react weak acid and weak base together, I mean, both are weak. Both are weak. Weak acid will give you few H positive ion. Weak acid will give you few H positive ion. And weak base will give you few OH negative ions. Okay. And what happened? Few OH positive ions will react with few OH negative ions, and together they will give you few water molecules. Okay. But the thing is that, is it complete neutralization? I mean, when we use stronger acid and stronger base together, there was complete neutralization because a stronger acid and a stronger base both are giving you a lot of H positive, a lot of OH negative ion. There was complete neutralization. But what about this one? There we are using weak acid and the weak base. Both are giving few ions. Weak acid is giving you few H positive ion. Weak base is giving you few OH negative ions. Okay. There is complete neutralization. I mean, final solution will be neutral. Final solution will be neutral. Why? Final solution will not be acidic. Final solution will not be basic. Because weak acid is, for example, weak acid is giving you few H positive ion. For example, it is giving you 20 H positive ions. For example,
I have a
it's giving
question.
you, yes.
So if it's a strong acid on a weak base, or if it's a weak acid on a strong base, still there will be less amounts of water produced, right?
Exactly, exactly. When you are using, okay, I got your question actually. Uh, Whenever you use weak acid and weak base, whenever you use weak acid and a strong base, or whenever you use a strong acid and the weak base, I mean, one is weak and one is strong. So you will get less water produced because the solution would be acidic or basic. Either acidic or basic particles will still be there in the solution, which need to be neutralized to give you more water. So you will get less amount of water. But if you are using a stronger acid and a stronger base, you will get a lot of water molecules. But and there will be complete neutralization when both are stronger. In case of weak acid and weak base, there will be complete neutralization because see, I mean, a weak acid is giving you only 20 H positive ion, for example, and weak base is only giving you 20 H positive ion. Both are weak. They will not dissociate into their ions completely. So 20 H positive ion will react with 20 OH negative ion, and together they will give you 20 molecules of water. Now there is no any OH negative ion and there is no any H positive and OH negative ion left in the solution. So there is no acidic or basic particle in the solution. So this neutralization is complete, but you will get few water molecules because it's still acid and base. They are not dissociating into their ions. As I mean, the solution will never be acidic until acid dissociate into ions to give you some acidic ions. Acid is giving you less acidic ion. Base is giving you less basic ions. You will get least amount of water. A few water molecules will be there. There will be complete neutralization. The, the final solution will be neutral, but still a lot of acid and base that is unreacted in the solution. And that is acid and the base, not the acidic ion, not the basic ion. The solution is neither acidic nor basic, neutral solution with few water molecules. And keep in your mind, this titration will never be considered. I mean, there is no point of reacting weak acid and weak base together because both are not dissociating into its ion. When they are not giving you their ion, they are not giving you their ion. How can you do the reaction or the products required ion so that you could react two ions together to make some product? Weak acid and weak base never react properly. So there is no point of reacting weak acid and the weak base. So this is just the example, but we never react weak acid and the weak base because they are unreactive. They are not dissociating into ions. When they are not dissociating into ions, you cannot make the product. So you can say the weak acid and the weak base titration, it is, I mean, there is no point of reacting these two things together because they are not giving you full product. They will give you 10 or 20% product. 80% of particles will be unreacted in the solution. No complete reaction will be there. This is a, and you cannot use any catalyst or something else to speed up the reaction. No, because they are not giving you their ions. They are unreactive. So these are, are these four type of titration. Is it clear?
Yeah.
Okay. Let's move to indicators. Which type of indicators we are using? Why we cannot use one indicator in all these type of titration? Okay. It depends. You know, we have different type of indicators. We have phenolphthalein. The name is difficult, but that is very common indicator that is less expensive. You can see phenolphthalein in your lab all the time. We have phenolphthalein. We have what else do we have? Thymol blue. That is called bromothymol blue. We are using methyl orange, methyl red. There are a lot of liquid indicators. These are liquid indicators. We usually add 1 or 2 drops of indicator to the acidic solution. As the reaction completes, indicator will change the color of solution so that you should know there is an endpoint of reaction. This is why, I mean, this is the reason that we are using indicators. But we have one more thing. That is, I mean, that is also indicator that is called litmus paper. You should know about the litmus paper. Litmus paper, that is totally different as compared to other indicator. I mean, other indicators are liquid. I mean, thymol blue, methyl orange, or you can say a bromophenol blue or methyl red. All the indicators are liquid and they have different mechanism. They have different usage. I mean, if you are using any indicator, so you have to add few drops of indicator into the solution and then you have to start your titration. As there will be endpoint, indicator will change the color and will tell you now stop the reaction because you are getting acidic solution, or you are getting basic solution, or you are getting neutral solution. So they are different indicators. But litmus paper is totally different. This is a paper. It can tell you the final result. For example, if you have a solution in a beaker, if you want to check the solution is acidic or basic, so litmus paper can tell you that the solution is acidic or basic. This is very common. Litmus paper, I mean, you can buy litmus paper from any stationery shop. You can check the, you can check lemon juice with litmus paper. You can check, I mean, you can add few drops of lemon juice on the litmus paper. Litmus paper will change the color and will tell you that either the lemon juice is acidic or the basic. This is how litmus paper work. That is very common. Litmus paper will not be used in the titration. That is totally changed. In titration, we use indicator which can be added into the acidic or the basic solution, which can change their color when there is an endpoint of reaction. Litmus paper cannot be added into the solution. That is a paper. It can tell you result at any instant. I mean, you can bring litmus paper, add litmus paper into the solution. It will tell you the solution is acidic or basic. Then again, add litmus paper into the solution. It will tell you that solution is still acidic or the basic. So we are not using litmus paper in the titration, but you should know about the litmus paper. We have 2 litmus paper, red and blue. We have 2 litmus paper, red and blue litmus paper. Acids, yes, acids. Acids are those substances which can change the red litmus paper into blue. Acids can change red litmus paper into blue color. All the acids can change red litmus paper into blue color. Acid will give you blue color. Acid will change red litmus paper into blue color. Acid will not do anything with the blue litmus paper. because they are already converting red litmus paper into blue. So if you are using blue litmus paper to check the acid, it will remain unchanged. So if you have red litmus paper, so you can check the solution. If it is acidic solution, so red litmus paper will turn into blue color. Or if you have blue litmus paper, you can still check your acidic solution with the blue litmus paper. Blue litmus paper will remain unchanged. It means the solution is acidic. If the solution is basic, so you cannot use red litmus paper because the bases or the alkali are those substances which can change blue litmus paper into red. So if you are using red litmus paper to check the bases, that will remain unchanged. Bases are those substances which can convert blue litmus paper into red, and acid are those substances which can convert red litmus paper into the blue. But we are not using litmus paper in titration. We cannot use litmus paper in titration. We are using different indicators for titration, but this is more important. It can tell you the final result, or it can tell you the acidity or the basicity of solution at any instant. Is it clear to you?
Yes.
Okay, so the next thing is okay, yes. So the next thing is indicators. So what indicators do we have here? We have